Hello my dear students, how are you all? Welcome to the Karnataka YouTube channel. I hope all of you are doing good. So as you know, we are doing PU1 chapters. So we're going to do today a master stroke for limits and derivative. Okay, it's a very important chapter. Reading reasons are like, of course the weightage is there, but as you know, from the PU1 there's not many marks coming in, but still it's a very important chapter from PU1 point of view. Reason is, again, there's questions coming in. Second reason, bacha, very important in PU2 chapters of calculus. Okay, so let's see what we have for the first thing. So limits. Okay, so what is the need of limit, bacha? What is the need of limit? For example, whenever a function cannot be defined at a point, for example, I can take here, I've taken a function like this. Okay, let's say I want to find the value of f of 2. Can you define it, sir? You can't define it. Please check. It will become 2 square will be 4 minus 4 upon 2 minus 2 gives me 0 by 0. So whenever you can see a function in this way, whenever you can see a function in this way coming like 0 by 0 or infinity by infinity like that, okay, so these are called as indeterminate form. Basically, whenever you cannot define a function directly at any given point, what we try to do is we try to find the limiting value. Okay, we try to approach the value x not at 2 but at, instead of writing here x equals to 2, what we do, we don't take this, we write 2 when x tends to 2. Instead of reaching there directly, we try to approach 2 from both the sides. Okay, so then we try to find the value of the function at that point, and that is called as the limiting value of the function. Okay, even though x is not exactly equal to 2, x is not exactly equal to 2, but the limit values which are always exact value. Okay, means whatever I get limit value, I cannot say limit approaches to that. The x approaches to the 2 when the limit value is this. Okay, let's say I'll solve this question for you. Okay, so whenever x, for example, in this question I'll get fx equals to 4 when the limit, check here, when the limit fx, x tends to 2, right? What happens? fx tends to 4. fx tends to 4. So even though x is not exactly 2, x tends to 2, but limit has the exact value of 4. We'll see how. So what we do in this question, we have to make some modifications. So whenever we arrive at situation like this, these forms are called as indeterminate form. They are called as 0 by 0 we have, infinity by infinity we have total of, I think we have infinity by infinity. Okay, so these are called your indeterminate form. What are these called? Indeterminate forms. Okay, now we have total of 7. For example, we have 1 to pi infinity. Okay, we have infinity minus infinity like that. Okay, there are total of 7 form, bacha. Total of 7 indeterminate forms are there. Okay, so whenever we arise this kind of situation, we have to look for limiting value, and what we do that, we try to use one of the methods. Sometimes we use factorization. Sometimes we use some special formulas. Okay, basically identities also we can also use. Same thing as factorization, no, but I'll write it separately. Identities we also use. Bacha, in 3 what we do, we can also use rationalization. Okay, and there is of course what you call some standard result. So we use all this approach to find our limiting value. In this question, what we're going to use? We're going to use the factorization. Please check. So we have the function fx given as x square minus 4 upon x minus 2. Right? If you apply the condition that x is not equal to 2, x is not equal to 2, I mean this is known, x can never be equal to, otherwise this is not defined only. Okay, so when this is true, what will happen, bacha? I can factorize this now. After writing the statement, I can factorize this. Before this I cannot factorize, but after writing this we can factorize it. It will become, please check, x minus 2 and x plus 2. X minus 2 and x plus 2 divided by x minus 2. Cancel. What I get, bacha? This as x plus 2. So my function has become this. Please check. My fx has become x plus 2. But when, very important, when x is not equal to 2, sir. Excuse me. When x is not equal to 2, sir. This is very, very important. Okay. This is the function's definitions now. Function's definition is given like this: fx equals to x plus 2 provided that x is not equal to 2. When that is known, please check how will this graph look like. It's a linear function, bacha. Please check. When x is 0, y is 2. Okay, over here. So this is the straight line. Okay, there will be a break over here and goes like this. Why is a break, sir? Because this point, please check, this point 2 is not there in the domain. This point 2 is not part of the domain. That's why before and after there will be a function, but at the point 2 you don't have the value of the function. Okay, so this is your limiting value. Please check, this value is nothing but 4. So how is right bacha limit? If you check here, limit of the function fx when x not equal to 2 tends to 2 bacha. Okay, I wrote it over here, not exactly 2, it will be nothing but 4. Please check here, try to approach this value 2 from this side. What is the value? Okay, closer to this over here, please check, 4 only. From here also we can put the value over here, no? Please check, if I put this value x plus 2 limit x tends to 2, what is this going to become? It will become bacha 2 plus 2 equals to 4. Whether you approach from left side or right side, the answer will be 4 only. The limit exists and it is equals to limit exists. For the limit to exist, what is the condition? The LHL and RHL should be equal. What is LHL, RHL? If you approach from this side, it will be LHL. Okay, approach from this side will be RHL. We'll talk about this, don't worry, but right now understand this. I hope you got it. Let's move on now. Okay, what we have next? Neighborhood of a point. Okay, so I have a point, let's say I have a point A over here. Okay, so what is the neighborhood of a point? You take a very small value delta over here and you take over here plus delta. This bacha is called as neighborhood of the point. Basically a minus delta, a minus delta to a plus delta, open brackets. Okay, a minus delta to a plus delta is called as neighborhood of the point O. It's called as NBD, neighborhood of the point A, sir. Please check. Neighborhood of A will be given by a minus delta to a plus delta. Have a look. Again, very important, open brackets. What is delta, Walla? What is delta? Delta will be a very small positive value. Okay, got it. Now something called as deleted neighborhood. From this neighborhood of A, what are you gonna do? Remove the A itself. Is there A over here or not? Yes, there is. So I write this again. Okay, so I write this thing again. We have delta here, we have delta here, negative and positive, and at A we'll put a open. This is A actually. So from the same thing, A minus delta to A plus delta, what are you gonna do? Remove A. This is called as deleted neighborhood of A. Please check. Done. You remove this A part from the neighborhood, you get the deleted neighborhood for yourself. Please check now. Let's move on. So now we are moving to LHL and RHL. So once we find these values, no, LHL and RHL, and then if they are coming equal, we call the limit exist. Basically, if I have the LHL value existing in nature and is coming equal to the value of RHL, what it means, bacha? It means limit exist. I know we are in the habit of saying that should be equal to the function value. That is for the continuity. If you put this equal to function value, no, it will become continuous. But for the limit, what is there? Only LHL and RHL should be equal. Is that clear? Okay, please check now. So whenever we approach, so I have, let's say, x tends to a as a part of the function. Well, we are looking to find the value of the limit. I can separate that into two parts. One of the part is over here. Please check. Basically, I have, let's say, in the function a over here. No, I have, let's say, a over here. This function was there, right? Please check. So let's say I have over here 2 or a. So when I approach this 2 from this side, we write this as x tends to 2 positive. X tends to 2 positive. This is called as RHL, right hand limit. Okay, but if I approach, if I do the same thing from this side, okay, it's called as LHL. How do you write it? X tends to 2, but from this side, from the left hand side. For the left hand side we write negative sign, and for RHL we write positive sign. Please check. Negative we write it as LHL. Have a look. LHL, and positive we write it as RHL. I hope this is clear. Okay, so the bounded function, we also have some state definition over here. A bounded function f is said to be bounded when we have two values k1 and k2, okay, such that, please check here, fx lies between k1 and k2 for all x belonging from a to b open. open A to B, please check. Okay, chali. So now we have algebra of limits, as we had in case of derivatives also. We have here as well algebra of limits, please check. So if we are given that we can find the value of limit of fx at a and gx at a, and they exist in nature, that's what the meaning of finding the limit is. Okay, then we can write this. If I have, let's say, to find the limit for the plus or minus of f plus gx, okay, f plus gx or f minus gx, I can separate the function and find the limits individually also. Result will be same goes over here with the product also. If I have a multiplication over here, I can find the limit individually, then multiply. Okay, if I have power over here, let's say, I can find the limit individually and then apply the power. Think that this has to be given equal to L, please check. Okay, and n has to be a natural number. Now again we have, if there is a quotient, of course this has to be non-zero, otherwise undefined. Okay, chali. Limit 1 upon fx, same thing we can do, provided this is again non-zero. What is L, bacha? This part is L, the denominator part is L, please check. Simple things are there. This part is nothing but L. Okay, limit of fx at point A is nothing but L. L cannot be 0, otherwise not defined. Okay, what we have next, if the limit of the function f at A is C and limit of the function gx is nothing but L, okay, at which point? At the point C, please check here. So basically the limit value is C and that C goes over here. Then I can write Goff. What is this, sir? Goff's limit at A will be directly L. Function f limit at A is C and function g limit at C is L. Then I can write, bacha, simply Goff limit at A is nothing but L. Goff limit at A is nothing but L. Too many marks, I'll just remove this part. Highlight, it looks too much highlighted. Okay, let's move on. Last one. Again, if you have, let's say, mod applied to the function, I can find the value of the limit and then apply the mod. Same thing. I have mod applied over here, I can find the limit value, then apply the mod. I'll have the same result, provided, of course, this is given as L. That's why I written here as mod L. Clear? I hope this is clear. Okay, moving on. What we have, again, for the exponential functions we have, bacha, I can apply limit to the fx directly over here, please check. Okay, same goes in the case of log also. I can apply limit directly to the function inside the log. Of course, this has to be positive in nature. Why positive, sir? Because domain of log is always non-negative. Sorry, only positive, not even non-negative. It can't be 0 also. It has to be only positive. Domain is what, bacha? Domain of log. Remember, domain of log, what is that? 0 open to infinity open. That's why, of course, this value of the limit of the function fx at point A has to be always greater than 0 or positive. Okay, chali. Evaluation of limits by using standard results. This is very important, extremely important. Limit of the function x power n minus a power n divided by x minus a, when x tends to a is nothing but n times of a power n minus 1. N times of a power n minus 1. Very important, where n is a rational number and a is any real number. A is any real number. Okay, n has to be natural and a has to be any real number. Okay, also true even if n is nothing but rational. You have seen that as well, right? Remember, x power 1 by 6, x power 2 by 3, like that is there. We can do that as well. Okay, n equals to either a rational number or a rational number. Okay, let's move on now. What is we having next? Evaluation of a limit when x tends to infinity. So far we saw the properties and functions when x was tending to 0, right? Or a actually. In this case, we are talking about x tends to infinity, sir. Okay. So what I've done, I've taken an example over here, 2x minus 5 upon 4x. So what we do in this type of question, no? We take the degree, we check the degree of the both numerator and denominator polynomial and divide both of them with the highest degree that we have. So what I have over here, highest degree is 1. Please check. This also is 1, this also is 1. So divide everything by x actually. You're gonna get what? 2x minus 5 upon x divided by 4x upon x. I can do that, no change actually, because same operation has done on both numerator and denominator, so remains unchanged. Limit x tends to infinity will be there. Have a look now. What I get this as 2 minus 5 by x upon simply 4. Put here limit x tends to infinity What I get, bacha? Put here. It will become 2 minus 5 by infinity upon 4. What I get? 2 minus 0 upon 4. How much is that? 1 by 2. 1 by 2. This is going to be 0, right? Okay. Remember? Okay. This is done. How come, sir? Please check. Please check. If I am writing infinity, what it means? 1 upon 0, right? 1 upon 0, right? If I am writing, bacha, 1 upon infinity, it means 0 only, na? It means 0 only. Correct? Okay. If you want, I can write it neatly for you, all of you. Very important, bacha. We're going to use this at multiple occasions. So very, very important. If I have infinity, I mean what, bacha? 1 upon 0. If I have 1 by infinity, what I mean is simply 0. Okay, chaliye, have a look. Done. What is we having next? Evaluation of the limits of greatest integer function. Think about it. Look at the function that we have. So we have here 0. 1 second. We have here 0, open, closed, open, closed, open, like this. Point is 1, 2 and 3, and this is also 1, 2. Okay, same goes over here. Open, closed. Again we have please check. Open, closed. The point is minus 1, minus 2. Here also minus 1 and minus 2. Minus 1 and minus 2. So basically, if you check, no, at every integer, okay, at every integer, so I call the points like this, or over here also. What is happening when x belongs to any integer? What happens, bacha? Please check here. After that point, basically when I'm going to x from the right hand side, RHL I'm finding out. What will happen? It'll come out as x only, no? So f of this, basically, 1 second. Have a look. So what I'll have, this will become, so simply x. Think about it. If I take this point 1, approach 1 from the right hand side, what is the value, sir? 1.000001. Basically I'm talking about this 1.00000000 somewhere 1. What is the answer for this, bacha? We know this answer is going to be 1 only. What is the answer? 1 only, right? This answer is going to be 1 itself. Have a look. Okay, the answer is turning out to be 1 itself. But if I approach 1 from the left hand side, let's approach 1 from the left hand side. Z minus I'm doing. Okay, what will happen, bacha? Please check. What will happen, sir? So 1 second. Yeah, so it'll become, please check, it'll become equals to x minus 1. Think about it. If I go like this, what I'm writing over here for the LHL part, what I'm writing, have a look. If I write here 0.99999, okay, all lines I'm writing, okay, all 9. What is the answer, bacha? Answer going to be simply 0, sir. Answer will be simply 0. I'll remove this. Answer will be simply 0. Yes or no? So if you go, if you try to approach this number before or from the left hand side, what is the answer going to be? Simply, what is the number was? Number was over here, please check. A equals to 1 if I'm taking. Approaching from the left hand side, okay. What is this going to be? 1 minus 1. How much is that? 0. Is 0 equal to 1? No, sir. Please check here. So my LHL is nothing but 0. My RHL is nothing but 1. I can say LHL is not equal to RHL. Therefore, limit does not exist. Limit does not exist. Okay, have a look. So same thing is written over here in brief. Whenever you're talking about RHL, it can turn out to be as it is A. But if you go in the LHL side, what will happen? It will become A minus 1. They're not equal to each other. Hence, limit does not exist. Limit does not exist. I hope this is clear. Okay, let's move on now. So this was a limit for your greatest integer function. Next we have the limit of trigonometric functions. Have a look. We have some standard definitions over here. Sin x by x equals to 1 when x is to 0. Sin x by x is 1. We have again this also is 1. We can take the reciprocal of this. That's why. Okay. Again, bacha, we have tan x by x equals to 1. This also same, because we can take the reciprocal, no, will come as same only. I can move this x on this side, okay, it will become tan x by x again. So 1 by 1 will be 1 only, okay. Again sin px by px will be bacha simply 1 times of p, okay. No, it will be 1 only, sorry, it will be 1 only, forgive me, when p is a constant, it will be 1 only. Same if you have tan px by p will be simply 1, okay, when p is a constant. Same over here, for x sin 1 by x will be 0, it will be 0, okay. And over here we'll have p square. How come? So because you have to multiply p square over here, no, it will become p square, over here it will become again p square, okay. Please check, you have to apply the formula 1 minus cos px will become what? It will become, sir, cos square of, no, yeah, sin square of px by 2, sin square of px by 2. Please check the formula. I told you, no, even the identity is used to find the limits, okay, one of the method to remove the indeterminate form. In the case of cos mx minus sin mx, what will have, bacha? N square minus m square by 2, okay. Important formulas are there. I hope you all remember these formulas, okay. Let's move on now, okay. So sandwich theorem, let f, g and b be real functions such that fx less than gx less than hx. We can see from the graph also. Have a look. So have a look, okay. So what we can do is write like this, okay. And I have 3 functions now. Fx is the least, so write from here. Then I have gx also, so write from here. I have hx also, write from here, okay. And at one point they are equal. The point can be x equals to a, okay. Write the functions once again. So I'll have this as, please check, fx, okay, this as hx, and this is nothing but gx, okay. Chaliye. So when this order is fulfilled, fx less than equal to gx and gx less than equal to hx, okay. And I have the value of limit of fx at a is nothing but L, and limit of hx also is same. Basically, the limit of fx at x tends to a is equal to limit of hx at x tends to a, and this value is both equal to the value L. Let's call it to be L. Then what will happen, bacha? Then of course, even for gx you'll have the same value. You'll have, means whenever you have the 2 extreme functions to be equal at any point, okay, so then it'll make a sandwich, okay. So what are you gonna get? Please check here. You'll have limit of gx as well at the same point x tends to a equal to L, equal to L. Got it? We use this in proof of questions of the theorems that we saw, no, the formulas that we saw in trigonometric function and all. We prove this using the sandwich theorem, okay. We can prove that as well. So K hub, what we have in knowledge of today, please check, limit of 1 by x when moving from the 0 positive means basically RHL is nothing but plus infinity, bacha, and from the left hand side is going to be negative infinity, and of course at 0 will not be existing in nature, will not be, because please check, no, before we have negative, after we have positive, are they equal? No, it means does not exist. What about this, sir? Same goes over here. We have that also does not exist. Please check sin x, sin of 1 by x also does not exist, and we have 1 upon ax plus b when x tends to minus b by a does not exist, okay. Again we have limit x tends to 0 for sin x minus 1 by x will also be dne, okay. Important results, please remember these results, okay. Same way, if we have limit fx when x tends to a as plus minus infinity, then limit of 1 by fx x tends to a will be 0, sir, will be 0, sir. Whether you take plus infinity or minus infinity, it will turn out to be 0 only, okay. Chali. What's the next part? We are moving to the derivatives now. Let's continue with the derivatives. Suppose f is a real valued function and a is a point in its domain. Of course, when we talk about continuity, differentiability, bacha, we talk about the domain, okay. That's why derivative is also here. Please check. So the derivative of f at a is defined from this principle. What is this called as? First principle, bacha, called as first principle of derivative. Again written over here. F dash of x is equals to limit of f of x plus h, minus f of x upon h when h tends to 0. Please check, same thing written over here. In this case we have taken a plus h and minus a, f of a minus f of a upon h, okay. But this is called as your first derivative principle, okay. Chali. Algebra of derivatives, we have done this. Very simple properties are there for sum. Remember, for sum, if I have fx and gx can be differentiable function, what we can do, bacha, please check. I can differentiate individually also. Basically, I have to differentiate the sum of those. I can differentiate individually and add them. Okay. Same goes in difference. If I have to find derivative of the difference of two functions, I can differentiate individually and then take the difference, okay, or take the subtraction. If there is a constant multiplied to this, bacha, what I can do, take it outside and write like this, c times of the derivative of the function. So basically constant is multiplied, I can keep it outside, okay, of the derivative. Moving on, product law, what we can do is, remember this, we have done this in PU2, keeping fx as it is, taking differentiation of the gx, okay, then keeping gx as it is this time and taking derivative of fx. In the case of product law, we don't have any preference, no preference in the case of product law. But in the case of the quotient law, what you have to do, remember, first has to be derivative has to be done for numerator. Okay, so you're gonna keep gx as it is and differentiate f of x, okay, and then next you're gonna what do, differentiate g of x and keep f of x as it is. Okay, I hope this is visible. If not, I can write it over here. So you can what you're gonna do, keep gx as it is and find derivative of x. F dash of x is called derivative of x, minus this time keep fx as it is, okay, and find the derivative of the denominator gx, okay, divided by square of the denominator, gx the whole square, Of course, gx cannot be 0, otherwise not defined, sir. Chali. Moving on, what we have now, derivative of polynomials and trigonometric functions, some formulas if you remember. First one, if I have to find d by dx of x power n, okay, what is the answer going to be? N times of x power n minus 1, n times of x power n minus 1. If I have, bacha, derivative of, let's say, to find what you call sin x, what will happen, bacha? It will become cos x. If I have to find, sir, derivative of, please check, cos x, I have this as minus sin x, okay. Fourth one, derivative of tan x, will have this as sec square x. Same way for cosec, will have a minus sine, cos and tan, okay. You also have for derivative of cot x, will become minus cosec square x, okay. And for derivative of sec x, you'll have this as sec x tan x. And same way for cosec x, you'll have, what will have, bacha? Cosec x cot x with a minus sign, okay. Do write that, okay. So let's move on now. Now we have some derivative for exponential function where base is a, you have a power x times of ln a. Whenever you have e power x, will remain as it is, e power x. First one, remember, their base is different here, base is a, not in natural value, e value is not there, okay. So we have base as a, what will happen? You're going to get this as a power x ln a, right? What is this? A power x ln a. What about this? It will become as it is. For log, what are you going to have? 1 by x, okay. So this is log with the base e actually, and this log with the base a. You'll have 1 by x ln a. This is the difference, okay. Let's move on now. Limits involving exponential and logarithmic function, very important. I've taken a question on this as well. Limit of e power x minus 1 upon x will be simply 1. Same goes with log, but you have a plus sign over here. Log of 1 plus x upon x we have. Please check, okay. And x tends to 0. Answer will be 1. Moving on, please have a look. First question. Let's solve the questions we have now. So the chapter is over, the concept part is done. I've taken 4 questions. We'll solve all these 4 questions and then complete the chapter, okay. So let's see the first one. Let fx equals to the given at the branching is given for the function from less than minus 2, between minus 2 to 2 and greater than 2, okay. Find a and b so that, okay, limit at 2 and minus 2 exist for the given function. Let's do for minus 2 first, okay. So if I find the value of LHL, it will turn out to be, please check from here. I have to use this part, no? I'm talking about x equals to minus 2 first. So I'll get this as, please check, it will become 3 minus 4, right? Yeah. This is equals to nothing but minus 1. What about RHL bacha? For RHL, I'll have this function. So it'll become minus 2a plus b, minus 2a plus b actually, which can be written equal to, from the limit definition, have a look. If you are taken equal to minus 2a plus b equals to minus 1, equals to minus 1. Okay, now let's move on. So this is one of the equation. This is one of the equation. Right, that's equation number 1. Okay, let's write at the point x equals to 2 now. What I'm going to get, if I'm writing LHL, I'll have this, to use this function, LHL will be over here. Have a look. So I get again 2a plus b is my LHL. If I'm doing bacha RHL, what I'll have? Please check from here. I get this as 2 square by 2. How much is that? Simply 2. So my equation will be 2a plus b equals to 2. Equation is over here. Add the equation. Okay, add the equation. Equation 1 and 2. So if I add them, I get here 2a plus b equals to 2, and I have minus 2a plus b equals to minus 1. Right? Correct. Cancel. I get 2b equals to 1. So b equals to 1 by 2. If you use this in the one of the function, what you're going to get? Please check. You're going to get 2a plus 1 by 2 equals to 2. So you're going to get 2a equals to 2 minus 1 by 2. So I'll have this as 2a 3 by 2. So a equals to 3 by 4. 3 by 4 and 1 by 2. Option C is right. Option C is correct. Have a look. Done. All good. Now question number 2. Find the value of the limit. Very good question. X tends to pi by 4 tan cube x minus a tan x upon cos of x plus pi by 4. Okay. So of course, for a denominator, I have to get the formula cos A, cos B minus sin A, sin B. So we'll have to need sin and cos in the numerator also. Something can be cancelled, otherwise it's not defined, right? So please check what we can do, bacha. What we can do, something we have to make use of over here. I have to simplify that first. So forget about the limit right now. Let's take the expression. So we write this as tan x common, tan square x minus 1, right? Upon, this remains as it is, cos of x plus pi by 4. Okay, I can write this again in the form of identity, tan x times of tan x minus 1, and I can write this as tan x plus 1 cos of x plus pi by 4. Okay, all right. Now write tan in the form of sin and cos. So you're gonna get tan x as, please check, sin x by cos x minus 1 times of tan x plus 1, okay, divided by cos of x plus pi by 4. This is so far so good. I'll take the LCM now. It'll become sin x minus cos x. So let's do that. So I'll have here tan x times of sin x minus cos x, okay, and of course divided by, I have cos x, and write this tan of x plus 1, okay, tan of x plus 1, and then I can write this same, no, this x will come, this cos x will come down, so write this over here next to this. So cos of x plus pi by 4, x plus pi by 4. Have a look. So what I'm going to do now, multiply this with root 2, and then what I'm going to get here also, I'll get divided by root 2, divided by root 2. Getting it? So I've taken root 2 over here, okay, and here multiplied with root 2. Okay, so I'll get this as, please check, I hope this is all visible to you. I'll have this as root 2 tan x. It'll become 1 by root 2 sin x minus 1 by root 2 cos x, okay, times of tan x plus 1 divided by, I have cos x times of cos of x plus pi by 4. Now please have a look. So if you check over here, I can make a sign change. I can multiply here minus sign. It will become minus over here and multiply positive over here. Basically, I am taking a minus common from here. It becomes negative, it becomes positive. So now I have, please check, minus root 2 tan x is of course there, okay, and I have this, I can write this in front. I'll write 1 by root 2 cos x minus I have 1 by root 2 sin x, and then I have the same thing again, tan of x plus 1 divided by, of course, cos of x times of cos of x plus pi by 4, cos of x plus pi by 4, okay. Now check carefully, very carefully. What is this, sir? Cos of pi by 4, cos of x, sin of pi by 4, sin of x, cos of pi by 4, cos of x, sin of pi by 4 and sin of x. What is this, sir? Cos of x plus pi by 4. So this and this is cancelled. This and this is cancelled. What I get now? I get this as minus root 2 tan x, okay, tan of x plus 1 upon cos of x. Now we applied the value of limit x tends to pi by 4. Have a look. I have here root 2 into tan of will become 1 again, pi by 4 will be 1 again. Okay, excuse me, there's a mistake in my expression. Okay, it was tan of x plus 1, right? So it will become 1 plus 1 divided by 1 upon root 2. Yeah, tan of x plus 1. So I get this as, this can be moved up, it will become bacha minus root 2 into root 2 into 1 into 2. How much is that? Minus 2 into 1 into 2. How much is that? Please check. Minus 4. Minus 4. Answer is option B is correct. Option B is correct. Have a look. Done? Good question. A very good question. Okay. Moving on now. Find the derivative of root 2x plus 2 root x minus 1 by root x. Very simple question. Take this over here. I get this as simply root 2 because for x I'll have 1, no? Derivative of x will be what? 1. How can you find it? From here, sir. X power 1 is there, no? Take 1 in front. X power 1 minus 1. How much is that? 1 times of x power 0. How much is that? 1. The formula of derivative. Okay. Oh, great. So I have root 2. What about this, sir? Same approach. I'll have this 2 in front of me as the coefficient. Okay. I write this as 1 by 2 because x power 1 by 2 is there. So 1 by 2 comes in front. And write x power 1 by 2 minus 1. And then I have minus sign. Again I'll get bacha, what I'll have, power is minus 1 by 2, no? So I'll bring over here minus 1 by 2. It'll become x power minus 1 by 2 minus 1. Okay. So I'm going to end up with, have a look, root 2, 2 and 2 is cancelled. So plus x power minus 1 by 2. I get here, please check. It will become positive. So I have plus 1 by 2 and become x power minus 3 by 2. Okay. So I'll end up with root 2 plus negative means comes over here. X power 1 by 2 means root x plus 1, root 2 plus 1 by root x. Plus sign is there, of course. I get 2. X power 3 by 2 bacha will come in the denominator, will become x root x. Remember this, x power 3 by 2. I can write here x power 1 into x power 1 by 2, na? Right? It will become x power 3 by 2. X is x, it will become root x. So x root x I have written over here. I hope this is clear. I can take now root x common in the last two term. So 1 by root x is common. I get here 1 plus 1 by 2x. 1 plus 1 by 2x. Option will be D. D. Please check. Good question. Not difficult, but good question. Okay. Have a look. Fourth one now. Limit of log 5 plus x minus log 5 minus x upon x is equal to how much? Okay. Is equal to how much? Let's solve this. It's a very good question. Let's solve this from the beginning. What we have here, bacha. So I'm going to do what? I'm going to do, okay, I'll take 5 common actually over here. Okay. So forget about the limits right now. We'll simplify this function first. So I take, in the log, I'll take 5 common. It will become 1 plus x by 5. Okay. Why this way, bacha? Because remember the formula for log has 1 plus x upon x in it. That's why. Okay. Minus, same thing. I take here 5 common. It will become 1 minus x upon 5. Okay. Alright. This will be as it is. I have x over here. Chaliye. Now log a into log b. Log a into b. It will become log a plus log b. This part is a. This part is b. So it will become bacha log a plus b. Right here, log of 5 plus log of 1 plus x by 5, same goes over here, minus log of 5, and there's a plus sign, so it becomes again minus, so minus log of, please check, 1 minus x by 5 divided by x, of course. I hope you get it. I'll again have log of 5 plus this part, no, there's a minus sign outside. Over here, it'll become negative again. It's nothing but, please check, x by 5 only, okay? Cancel. What I get now? Log of 1 plus x by 5 upon x minus log of 1 minus x by 5 upon x. Now do one thing, divide by 5 and multiply by 5. Here also, divide by minus 5 and multiply by minus 5. Okay? Now check this result. What is this going to be? I have 5 in the denominator, will become 1 by 5 over here. Okay? And then I have log of, please check, 1 plus x by 5 upon x by 5. Okay? What next I have, bacha? I have minus, have a look. I have minus 1 by minus 5, no? Log of, please check, 1 minus x by 5 upon minus x by 5. I'm taking this minus 5 over here actually. Okay? It'll become plus now, of course. What I'm getting now? Now I can apply the limit, bacha. Now I can apply the limit on both of this. I can apply the limit on both of this. Okay? Limit x tends to 0. What I get now? Have a look. So for this I'll have 1 by 5. Apply limit on this. It'll become 1. Okay? Again you'll have 1 by 5. Apply limit on this part. It'll again become 1. Answer will be 2 by 5. Answer will be 2 by 5. Option B is correct. Option B is correct. Please have a look. Excellent question. Excellent problem. Okay? So I hope this is alright. So this completes our session today. I hope you had fun. Let's move on. Okay? Chaliye. So this is done for the session today, bacha. This completes the session on PU1 chapter, limits and derivative. KCET master stroke for statistics, again for PU1 chapter. It's very important chapter because question can come in the standard deviation part, mean deviation part as well. Okay? Simple questions, very simple concepts are there. We'll go through it right now very quickly. So please check here. So first thing coming up for you is measure of central tendency. Okay, now if you check over here, again we know that we have a mean, median and mode. We have learnt it for so many times. We have learnt in grade 8, 9 and we have seen the glimpses of it. We learned today as well. So what is mean, sir? We also call mean as average of the given data set, whether discrete, continuous, whatever is the case. We have the data set and we find the average of that by taking sum of all the values divided by number of these values. Means let's say I have 5 values which can have a value of each as 102, 100, 105 like that, and you add all those values divided by number of those data points. So if I read this, mean is calculated by adding up all the values, same thing. Okay, divided by the number of items that we have. Again for median is the middlemost value of the given data set if you have arranged the data in the ascending or descending order. Yes, you have to arrange the data in the ascending or the descending order. Once you do that, you find the middlemost value, you can get to find the value of median. Again, if you have odd data places, for example you have 1, 2, 3, 4, 5, a total of 5 data sets, then how you find median, sir? So you can check here, this is the middlemost value. So this value will be your median after arrangement of data in the ascending order. I'll repeat myself. If you have only 5 data points actually, then the middlemost value is third value. Please check. This is the case for odd. If I move on to the case for even, let's check here. I have 1, 2, 3, 4, 5, 6. Okay, over here I have 6 data points. Then how you find median, sir? You have to find, please check here, you have to find the average of these 2 data points. Again, you have to arrange first. First step is to arrange. This is step 1. Okay, step 2 will be to figure out the number of data, whether it is odd or even. For odd, simply the middlemost value is the median. But for even, what you do, you find the average of the middlemost values. Please check here. So the third term, you find the average of third and fourth terms. Okay, over here median itself is the third term. Third term is the median. Over here we have to find the average of third and fourth term. I hope this is clear. Let's move on now. So again, you have the formulas. As I said, if it is given for odd numbers, you simply write this as n plus 1 by 2. Please check here. The n value was, bacha, in this case 5, right? How do you find this? N plus 1 by 2. How much is that? 5 plus 1. 6 by 2 is how much, sir? Third value, right? Third value. Whereas in the case of, if the number of observation is n is actually even, what do? You find the average. Check here. 1 by 2, which is nothing but average of the n by 2th term. 6 by 2 is third term. And 6 by 2 plus 1, fourth term by 2. Did I say that the same thing? Please check here. Third term, fourth term, average, right? So third term will be n by 2th term, and n by 2 plus 1 will be fourth term, okay? Average of that will be your median value. Please check. Again, for mode, simplest, whichever is data is coming for the maximum number of time, okay? Since the frequency is the highest, that is called as the mode of the given data set. These three are the measures of central tendency. Okay, now moving on. Acha, there are three very important formulas that we have to remember coming from AP. Okay, and other sequences that we have. Sum of first natural numbers is given by n times of n plus 1 by 2. If you are dealing with sum of first square of natural number, sum of first n squares of natural numbers. Natural numbers is given by n times of n plus 1 times of n plus 2 by 6. Okay, by 6. All right. Please check. But this has to be 2n plus 1, right? N into n times of 1 times of 2n plus 1 times of 2n plus 1. Please check. It will be, sir, coming as 2n plus 1. Okay, so and we have this n cube equals to n into n plus 1 by 2 the whole square. Okay, moving on to next part. So what we have now, please check. So over here we have measure of dispersion. Okay, over here only we'll talk about deviations, right? Variations and deviations. Please check. Dispersion is the measure of the variations. Dispersion measures the degree of scatteredness. Very important word. Degree of scatteredness of the observation in a distribution around the central value. Very important, two important words. Scatteredness around the central value. Okay, for a given observation that you have, I have the central value. What is that? Mean, median and mode. Over here we mostly discuss with mean, respect to the mean only, but you have seen in the boards, right? We also have for the like median as well. We also have, like, you know, division with the median, division with the mean also is there, but right now we'll talk about mean only. So with the mean, how much scatteredness is there or present in the given observation, that is called as your variation. Okay, so in other words, the degree to which the individual values of the variate, okay, fall or scatter from the average values. What is average values called as? This is called as, sir, mean, medians and as such. Okay, from the mean or from the median is called as the dispersion. It's called as the dispersion. Okay, we find it using this. So we have the measure of dispersion as range, quartile deviation. Okay, we have mean deviation, we have standard deviation. This is the most important part for our syllabus point of view. Very important, sir. Okay, please check. Now in the range, very simple definition: maximum value of the observation minus the minimum value of the observation. Whatever observation is given to you, know, whether it is age, anything is given, population, in that the maximum value minus minimum value will be your range of the given data. Range of the given data. Okay, it is used in stock market and in calculations of mean temperatures of a certain place. It is used a lot of times. Okay, some examples are given over here as well. Let's move on. So if you check here, variance and standard deviation, over here the questions will be coming. I have listed the formulas over here. You have to remember this. You have to remember this. Remember, once you find the variance, your standard deviation will be nothing but root of variance. Okay, so let's read it. Variance and standard deviation. So we have variance is the mean of squares of deviation of variate from their mean. Means we are talking with respect to this. Check here, x bar is called as mean only. Okay, so from the mean, how much deviation is there? What does this mean, bacha? This xi minus x bar means deviation. Please check, deviation from mean. Okay, and we're dividing this by n, right? Please check, dividing by n. That's why it is average. Already said it. Mean means, this means average. Square is already there. Please check. Mean means average of the square. Mean means average of the square of the deviation. Please check. Average 1 by n represents average of the squares. Sum is of course there. Okay, that's you find average, no sum. So average of the squares of the deviation. This is the deviation part, right? Yes, I hope this makes sense to you. This summation by n represents average, right? This condition represents average, right? And this represents a deviation. Of course, the square of the deviation. That's how you read the statement. Average, mean means average of the squares of the deviation of a variate from their mean. It might look confusing to you, but it is actually very simple. I'll repeat once again for all of you. The definition of the variance is very simple. It's nothing but the average. This mean represents average. Please check. This represents average of the square of the deviation. This part, bacha, xi minus x bar is nothing but deviation. For deviation of what? Deviation of the variate from its mean. This is the mean. X bar is the mean. Makes sense to you? And 1 by n and summation is the combination of average, right? You add sum of all, divide by the n, total number of the items there. So n. Okay, so this is the definition of it. It is denoted by sigma squared. Sigma, and that's how you read it, sigma squared. Okay, because sigma is standard deviation, so variance is given by sigma square. We just said no, standard deviation is nothing but square root of variance. So basically the variance is sigma square, na? If you take the root, it becomes a sigma only. So sigma is nothing but the notation of standard deviation. Sigma square is for the variance. Does it make sense to you? Yes. Okay. The positive square root of the variance of a variate x is known as standard deviation. Very simple, right? Very simple. Okay, chaliye. So given like the root of variance x. Now we have the formula. I already explained this to you, where x bar is the mean of x1, x2. All the observation is there. x1 is the x2, x1, x2, xn are the observations. For that you find the x bar first, then you find the deviation, then you take the square of that, then you add all of them together, divide by number of items will be your variance. Yes. Okay. So this is when bacha all the elements are individual. There is no frequency present over there. If you have frequency, you have to multiply this with fi also. Please check here. You have fi also present there in that case. If you have frequency, multiply with fi. Of course, we are finding here standard deviation. That's why root is there. Okay. Please check. Okay. Same thing. Root part here also. Conditions are different. Discrete frequency. This is for continuous frequency case. Okay, chali, let's move on to questions now, shall we? Okay, so before that we have some properties. Let's go through that as well. So variance of, if you have a scalar added to a lambda added to xi, okay, the deviations, the observations will remain same. You'll have variance of xi. There will be no change in this. Okay, so variance of xi plus lambda will remain as variance of xi only. If the lambda is added, no change. Okay, but if it is multiplied, okay, if you had xi plus lambda, no change in variance. Okay, but if you have lambda times xi, if the scalar value, the constant value is multiplied to xi, then you'll have to write this lambda square times of the variance. Okay, chaliye. If you have bacha, let's say this case, axi plus b. For a, you're going to multiply this with a square of, again, variance of xi, and for b, no change. For b, because b is added, right? For this scalar value will have no effect, whereas this a will be taken as a square. I hope you understand that. Okay, simple understandings, because this can be used in the question. That's why. Okay, moving on now. So we have question number 1. I've taken 3 questions just to understand the chapters that we have and learn the how to apply the concepts in the questions. That's all. Okay. Again, we'll do more questions, as you know we are doing. But right now we'll focus on your concept part only. Okay. One short goal is to complete all the concept. Questions I actually have taken. It was not supposed to be there, but I've taken questions because I want you to not go without hand of any question practice. Okay, that's why I've taken the question. Otherwise, there should be no question in the one shot. Chaliye. So standard deviation of the first 2n plus 1 natural numbers is equal to what? 2n plus 1 natural numbers. So first find the average of that. Please check how do you find bacha average of this. So if you find the average of this, you'll go from 1 to, I'm trying to find out x bar all the way till 2n plus 1. Okay, you'll have divided by, please check, 2n plus 1, correct? You'll have the formula for this, no? You'll have, there are how many natural numbers, bacha? If there was n, you write it as n into n plus 1 by 2, right? But in this case, we have 2n plus 1. If we had formula for, remember, if we had n natural numbers, we'll write this formula as n times of n plus 1 by 2. In this case, n is nothing but 2n plus 1. So write this as 2n plus 1 times of 2n plus 1, no? N is 2n plus 1, right? So right here, 2n plus 1 divided by 2. Okay, by 2 is there, and of course this value is there. Because bacha, this part, no? This part is taken like this. Please check, 2n plus 1 times 2n plus 1 by 2. Because I'm putting this n value as 2n plus 1. I hope this you get this. Okay. Now I'm getting from here, this and this is cancelled. I'm ending up with 2n plus 2 divided by 2. So I cancel this 2 and 2 again. You have the value of this as n plus 1. So basically my x bar is coming as n plus 1. The mean is known now. Okay, we're looking for standard deviation. Okay, sigma, so we'll have a root, of course, and then I have, of course, we'll have a summation, but we also have 1 by n, so 1 by 2n plus 1 will be there. 1 by 2n, because n itself is 2n plus 1, so I'm writing here 1 by 2n plus 1 is there. Then summation, of course, summation of what, bacha? Summation of xi minus x bar the whole square, xi minus x bar the whole square. Excellent. Please check. So 1 by 2n plus 1, again you have a root, of course. I can write this, please remember, starting from 1 to 2n plus 1. If you go about that, if you write like this, let me check. If I'm writing here x1, okay, minus x bar. What is x1 value, bacha? First term is 1, no? Like this. First term is 1, sir. So right here, 1 minus n plus 1. How much I get? I get here 1 minus n minus 1. 1 and 1 cancel, I'm getting here minus n only. But there's a square to this. So I get here square. It means I'm going to get first term as n square. First term as n square. And same goes from n square. Then I have here, please check, n minus 1 whole square. So on till 1. Okay, but since I have actually, excuse me, since I have here not n term, we have n plus 2n plus 1 term, we'll have the same thing repeating twice, bacha. Please check. Since I have, this is for n terms, right? Starting from n to 1, but I have total of 2n plus 1 terms, then same thing will repeat 2 times actually. So we'll write here 2 outside. Okay, 1 into 2 is not 12, it is 1 into 2. Okay, now let's go about this, what I'm getting here. Have a look. My sigma will turn out to be, I have 2 times of in the root, of course. What is this, sir? Summation of all the square terms. What does this represents? Summation of all the square terms. This formula is nothing but n times of n plus 1 times of 2n plus 1 upon 6. We just learnt it. N times of n plus 1 times of 2n plus 1 upon 6. So write that 2n n plus 1 2n plus 1 upon 6, and this was already there, so we'll write that also 2n plus 1. This and this is getting cancelled. I have, please check what I have, bacha, here 2 3s are 6, no? So I'll have the answer as n times of n plus 1 by 3 in the root. This is a sigma value. Option is coming as C, right? Yeah. This is the value of standard deviation, C. Option is C, sir. Please check. Okay, done. Question is done. It's a very good question. Extremely good question. Have a look. Okay, moving on to the next question. Question number 2. The mean deviation from the data 3, 10, 10, 4, 7, 10, 5. Mean deviation, bacha, we have to find the mean first of all. Basically, what are they asking? They're asking you find the average of the deviations. Okay, so how do you find that? How do you find that? So first of all, you have to find the average. Please check. You'll have 3, 10, 10, 4, 7, 10, 5, 1, 2, 3, 4, 5, 6, 7. So we have total 7. We get here 30 plus 10, 40, 49. 49 by 7. How much is that? 7. Okay, do it. Do your own calculation to find this mean. So I get x bar as 7. Now I have to find xi minus x bar, right? Summation of xi minus x bar by n, right? Please check. So I'll have this value as, so 7 minus 3. Okay, of course there will be mod, of course, outside, because we want only positive values, no? So mod will be there, not only here. I'll just change it. This mod will be over here actually. This mod will be over here actually. All right, so let's start. We'll have 3 minus 7, so negative is there, but will become 4. Again we'll have 10 minus 7, so 3, 10 minus 7, again 3, 4 minus 7, again 3, 7 minus 7, again 0. You'll have 10 minus 7, you'll have 3, and 10 minus 7, 5 minus 7 will be minus 2. Mod will make positive, so plus 2 by 7. 4 plus 3 is 7, plus 3 is 10, plus 3 is 13, plus 3 is 16, plus 2 is 18 by 7. Any option like this? 7 2s are 14. Okay, less than 3, more than 2. Option B is right. Option B is correct. 2.57. Moving on to question number 3 now. The last question of this chapter. So mean and standard deviation of 100 items. Okay. Mean is given, sir. X bar is given as 50 and sigma is given as 4. Can you find the sigma formula we have, right? So we have this 1 by n, okay, sigma xi square minus x bar. Already we have x bar square, and we have equal to, okay, that is it, no? That is given as 4 actually over here. So let's write this. Continue from here. 1 by 100. I get, in this case, please check, sigma xi. What are they asking over here? Sum of all squares of the item, right? So they're asking this only, no? Sigma xi square. Correct? Now x bar is given as 50, so right here 50 square, and right here 4 square. Because I'm taking the square of this whole expression, it will become square root will cancel, it will become 4 square. Square root will cancel and it will become 4 square. So I have over here sigma xi square upon 100, it will be minus 2500 plus 16. Please check over here, it will become plus 16. So I'll have 2516 equals to sigma xi square by 100. Simplify this. Sigma xi square equals to 2516 multiply with 100, so 00. 251600. Option is A. So this completes the chapter statistics. Okay, so I hope you had fun. You learned something. So this will be the end of the session. So end of this particular chapter. Let's move on. Chapter is probability. Okay, it's an important chapter because questions can be clubbed or can be asked from PU1 and PU2 as well, okay, individually, and they can be clubbed together as well. So make sure that you have visited this chapter, learn this chapter in detail. Okay, so we're gonna do this entire chapter from PU1. Also, I've taken some questions at the end to help the fill the gap that you have between the concept and the problems. Okay, so let's start. So what we have first thing is, please check some definitions. Very important definitions are there, just to understand them. If you can understand them clearly, then of course you will be able to solve the questions very easily. Okay, so understand the definitions very clearly. So first is event. Okay, so elementary we have in the event, of course in the event we have types of events. Okay, so we have very simple elementary or simple events, and an event which has only one sample point. Okay, example you can take, bacha, please check here. So in an experiment of tossing 2 coins, the sample space is HH, HT, TH, TT. Okay, and there are 4 simple events corresponding to the sample space like this, bacha. Event E1 HH, event E2 HT, event E3 TH, and event E4 TT. These will have unique places in the sample space, won't they? All these events, so event E1, event E2, event E3, and event E4 will have unique place in the sample space S. Please check. Okay, that's called as simple or elementary event. Simple or elementary event. Okay, so that's all. Please check sample point of the sample space S forms an elementary event. Every sample point, okay, means every point will have one event associated to it. We'll be calling that as elementary event. Okay, very simple. Few more definitions are there. Let's have a look. So impossible event, an event which does not contain any sample point. of the sample space is called as impossible event. Okay, basically probability is 0. Okay, now certain or sure event, when you have all sample point, basically probability is 1 bacha. For this we know that probability will be 0. For this the probability will be, what's a 1 bacha, will be 1. Okay, so an event which contains all the sample points of the sample space S is called as sure event. In other words, an event which is certain to happen or to occur is called as sure event. Okay, chaliye, so for example, when an unbiased die is thrown, then getting a number less than 7. Think about it. On a die we have 1, 2, 3, 4, 5, 6. Any number less than 7, we have all of them, right? 1, 2, 3, 4, 5, 6. All of these are less than 7. It means if you define the event like this, less than 7, then of course all the sample point will be part of the sample space. Yes or no? Please check. Yeah. So for that case, you can call this to be sure event. Okay. The sample space S describe event and it is called as sure event. Basically, you'll have this now, S by S. Okay. So it will become simply 1. The probability will become simply 1. All sample point will be part of the sample space. Please check. So compound event, an event which has more than one sample point is called a compound event. Let's look at example. When an unbiased die is thrown, then getting an even number of die. Okay, an even number. I can have more than one even number or not? Yes sir. Please think. I can have 2. For this particular event, I can have 2, 4 and 6. Okay, we have multiple sample point you have. That's called as compound event. So we had elementary, now we have compound. Okay, so when an event which has more than one sample point, okay, same event. What is the event, bacha? Please check. The event was getting an even number. For the same event we have 3 sample point, 2, 4 and 6. Hence it is called as compound event. Getting it? Let's move on. So events are a subset of the sample. Okay, algebra of events. Okay, so of course whenever you take 3 events, let's say A, B, C, okay, for any experiment which is given, okay, it's part of that event, and basically A, B, C will be a subset of the sample space S. Correct, na? For the whole sample space S, what happens, bacha? You have A, B, C as basically subset or any event in the sample space based upon any experiment. Okay, the experiment can be tossing a coin, die is thrown, we are using a card setup, whatever it is. For any given experiment, there's a sample space, and ABC is part of the sample space. Basically ABC is the event in the given experiment. Okay, so please check. So events are subsets. That's what I said, right? ABC are subsets of the sample space. ABC are events, those are subsets of the sample space. Okay, therefore algebra of events uses operations on the set theory, namely what which we use union, intersection, difference and complement. Okay, have you seen this? Of course you've seen this in set theory. Yes, we've used this also, this and this as well. In the case of set theory, we have learned all these definitions, right? Intersection of 2 sets or event, union of 2 events, difference of 2 events. But in this case, we'll learn to find the not only intersections, we'll learn to find their probabilities also. Okay. First one, complementary event. For every event A, there corresponds another event denoted at A dash, A prime, whatever you call this, or A bar you write, or AC you write. All means the same thing as complement of event A. What it means, sir? Complement of event A. Complement of A. Complement of A is written as A dash, A bar or AC. Okay. Basically what it means is everything in the sample space except for event A. What it means, sir? Everything in sample space S, everything in sample space S except for A, except for the event A, right? Event A is subset of sample space S, right? We know that. So everything in the sample space S except for A. Okay, that's the definition of your complementary event. Please check. So we have written here for corresponding event denoted by A that AC, called complementary event to A, or called event not A, whatever is not A. Okay, it is defined as event consists of all those elements of S which are not in A. Okay, everything in S which is not in A. Okay, chaliye, so think about it. So basically this AC becomes equals to total sample space S minus the event in A, minus the sample space or the elements of the set A or the event A. Let's move on now. Complement is clear. For example, if S is HH, TT, TH and HT and A is given as HH and TT, what is bacha AC? AC will be except for these two, no? So to remove this HH and TT, so remove these two. What is the answer going to be? TH and HT. That's your answer. TH and HT. Okay? TH and HT. You can check here. That's going to be your complement of the event A. Okay? Of course, it has to be defined with respect to the sample space S. Right? Because A is a subset of sample space S. Okay. Now, the event A and its complement A dash can't occur simultaneously. Think about it. Can they occur at the same time? Can they occur simultaneously? They cannot, right? Can you get head and tails at the same time? Can you get that? You cannot get that, right? Because of course both events are cannot be existing in the same point. Okay, for example, if outcome of above experiment is HH, then we can say that event A has occurred but the event not A has not occurred. Okay, means if I have HH, okay, I cannot say that can we get TH and HT? We cannot get that, right? Okay, the event A or B. Now we have the most useful, very commonly used in all the problems that we are having. All of them actually. Complement is also used, even union is used, even intersection is used, but you can see union coming more occurring at maximum number of times in the questions. Okay, so union of events, what is this? Please check. So you write it like this. Two events are there, A and B. Again, A and B are subsets of the sample space S. I keep reminding you guys. Okay, then we write this as A union B. So basically it means it's in either of them. Okay, so think what is either in A or B or in both Okay, so event A or B is same as the event what bacha? A union B, and contains all those elements which are either in A or in B or in both. Please check. This is the notation, right? A union B. Moving on. For example, suppose a die is rolled if A be the event of getting an odd number and B be the event of getting a multiple of 3. You rolled a die, right? Odd number, event A is what? Event A is getting an odd number. Event B is getting a multiple of 3. Then the event A or B will be what? All the numbers. So all the odds, which is 1, 3, 5 and multiple of 3. So this is 3, 6, right? So you're going to take the combination, it will become 1, 3, 5, 6. This will be your union of A and B. Union of A and B. Please check. Same thing written over here. 1, 3, 5, 6, right? You will not write the repetition. You know this. We have learned this in set theory. Okay, no repetition is required. Okay, so you're going to write this set A represents only the odd numbers when you throw a die. Okay, and set B represents only the multiples of 3. So when you combine them, when you take OR the case, you have to club these sets together. Answer will be 1, 3, 5, 6. Okay, note if the event A or B has occurred, then we can say that at least one of the events A and B has occurred. Or means minimum of 1 is okay. Okay, and when we say basically in the case of intersection, we have to take both should be at the same time. Okay, we'll see that. Next is that only the event A and B. Event A and B. Think about it. There was OR in the previous case, right? We had OR over here. In this case, we have AND over here. There's a difference. Okay, when we say AND, we mean this sign, intersection sign. Okay, so we call this to be intersection of two events. Okay, written like this. A intersection B. Basically, if you have to apply for the same case now, what is the answer going to be? Only 3. If I'm looking for intersection of A and B from here, let's say I'm looking for the intersection of A and B, what is the answer going to be? Just 3, sir. Just 3. Okay, let's look at this. Event A and B is same as the event A intersection B and contains all those elements which is common between the two sets or common between the two events A and B. Okay, chaliye. If A and B are complementary events, then of course union will become sample space. Complementary means what, bacha? Complementary means, think about it. If whatever is, let's say I call this to be, this is total S. Okay, this is my A, and this remaining part is B. Excuse me. This remaining part is nothing but B. Okay, this remaining part is B. So what is the intersection of A and B, bacha? Nothing. B is not the rectangular part. Okay, rectangular part is S. Okay, A is the circular part and B is the remaining part if you remove the circle out of it. Basically this is B. This is B part. This is the B part. Okay, so if you take union of both, A, union B, if you take, what is the answer going to be? Answer will be, sir, simply what, sir? Sample space S. That's what I've written here. But if you take intersection, what is the answer, bacha? What's the answer for intersection? Will be null set. Nothing is there. Can you find any intersection between A and B? Anything common between A and B? No, sir. That's why nothing is there. Hence null set. 5. Okay. A intersection B is 5. A union B is entire sample space S. Okay. Chali. Now event. Okay. Now we are talking about difference. Means in A, present in A. So present here and here absent. Something, the element which is present in this case but absent in the case of B. Okay, that is the result. A but not B. Difference of A and B means A but not B. If I write B minus A, it will become, bacha, B but not A. B but not A. Please check. The event A but not B is same as difference of A and B and contains all those elements of the sample space S which are present in A but not in B. Present in A but not in B. Okay, please check. Alright, A minus B is equals to A intersection with B transpose, B complement. Okay, if W is the set of this, W is the element of the set, okay, and W belongs to the set A and not with B. Correct. Now what is W, bacha? W is the element of this set A minus B, okay, which belongs to the set A but not to B. That's what it says. In A but not B. In A but not B. Very simple. Moving on now. So can you see, differences are very, very important. These differences are very important, very, making sense for you to solve any question. Moving on now, some more definitions we have. Mutually exclusive events. In an experiment, 2 or more than 2 events are said to be mutually exclusive if happening of one rules out the happening of other or occurrence of the other, right? If I'm getting, let's say, tossing a coin, getting a tails, means I cannot get head, right? Means occurrence of tail, remove the occurrence of the chances of occurrence of the heads, right? So those are called mutually exclusive events. Mutually exclusive events, okay? So event E1, E2, En of a sample space, if of the sample space S are mutually exclusive, then what bacha? Intersection will be 0. Intersection of all these events will be 0. How come, sir? Can you get them together? Something is common between them. They are mutually exclusive, right? Then you cannot have something common between them, right? Hence, it will become 0. Please check. Exhaustive events, okay? E1, E2, En are events of sample space S. Called exhaustive only if you take the union of all of them, you get the resulting as simply sample space, okay? The entire sample space, okay? So if you write like this, E1, E2, E3 unions together till En, answer should be sample space, okay? Then E1, E2, E3 will be called as, up to En will be called as exhaustive events of the sample space S, okay? Yeah, okay, chali. Now what else we have, so? Anything important? In other words, event E1, E2, En are said to be exhaustive if at least one of them necessarily occurs, okay? Yes, this is very important. At least one of them necessarily occurs, okay? Means, let's say tail and head I take. If I toss a coin, will tail or head not come? At least one of them will come, right? Unbiased coin is there. If I'm tossing it, I'm saying that, yes, they are exclusive as well, means I cannot have tails and head at the same time. If I'm getting tails, I cannot get heads. That's okay. But one of them has to come, either tail or head, whatever it is. But one of them has to come for sure. That's why I'm saying that at least one of them necessarily occur. This will also be a case of exhaustive events, okay? Whenever the experiment is performed, if you're tossing a coin, this experiment, you're getting at least head and tails, right? One of outcome will be, of course, there. Then, if intersection of the events should be phi for any I not equal to j, event Eij are pairwise disjoint. Pairwise disjoint. Again, nothing in common, okay? Chali. Then events E1, E2. Why I'm saying this? Because this actually is going to be very, very useful for you to remember this. Definition of base theorems come from here only, right? Right? Mutually exclusive exhaustive events. right? Chaliye. So then if you have the case no true, what happens is, which case sir? This case mutually exclusive and basically pair by disjoint and of course exhaustive in nature. It becomes what, bacha? This can be definition of the building block for Bayes theorem, okay? And you call this event to be all the events. If this is true, then the event, this condition is true, then what do you write? E1, E2, En to be mutually exclusive and exhaustive events. Mutually exclusive and exhaustive events. Next is what, sir? Equally likely events. Means for the, let's say for I have n events and outcome of each has to be equally likely. Okay, means half of chances. If I have 2 events, means half of chance. 3 events means 1/3 chance. Okay, so if I have n events, means 1 by n chance. Okay, same thing written over here. Please check. Yeah. Yes. So in experiment, 2 or more outcomes events are said to be equally likely if they have same probability associated with them. Okay, no one of them has more chances of occurrence than others. Right? Coin toss. Think about it. Head will have half a chance, tails will have half a chance, right? None of them has more chance of occurrence than the other. Please check. Chaliye. Now, axiomatic approach of probability, which we have 3 simple axioms to understand over here. Very, very simple. Please understand. For any event E, okay, for any subset of S, P will always be positive or 0, okay, and of course cannot exceed value 1. PS will always be equal to 1, axiom 2. Of course, if E and F are mutually exclusive events, answer of union will be simply in the sum, right? Because usually what we do know, we write here union of F given as PE plus PF minus PE intersection F. But since they are mutually exclusive events, this value will turn out to be 0. Hence, your result will be this much only. Please check. Okay? Chaliye. Probability of an event having equally likely outcome, same thing I was saying. Okay? It means, let's say all the events have the same probability. P, 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 like that. I can add this for n times. I can add this as NP. Okay, hence my P will turn out to be, if NP equals to 1, why 1, sir? Probability of entire sample space, how much is that? Always 1. Okay, so you'll have NP equals to 1. It means P equals to 1 by n. P equals to 1 by n. Probability of one event will be 1 by n. As I said, if you have 2 events, 1 by 2, 1 by 2, 3 events means 1 by 3, 1 by 3, 1 by 3. If you have n events means 1 by n plus 1 by n plus 1 by n times will be equal to 1 only, right? Okay, now let E be the event associated with the S such that n is given as m. We can write this as ne by ns, it will become m by n. M by n is given as m, right? So m by n. Please check 1 by n plus 1 by n plus 1 by n, so that n times you'll have m by n. Why m by n, sir? Because n is given as m, bacha. N is given as m, sir. You're looking for the probability of the event E, right? That's why. Chaliye. So let's move on now. Addition theorem. Explain this right now. Please see this. Right now explain this part. Okay. A and B will be given by PA plus PB minus PA intersection B. Okay. What else we have? If I have 3 events PA union B union C, I write it as PA plus PB plus PC minus PA intersection B minus P intersection C, B in C, and then you have to add the intersection of all the 3. This is addition, right? Yeah. This is the addition of intersection of all the 3. A with B, B with C. This is C, sir. Okay, this is C. Okay, and this will become equal to simply PA plus PB plus PC if they are mutually exclusive events. How come, sir? Then because what will happen, bacha? Answer will be 0 for this. This all values will be 0, sir. PA intersection B equal to PB intersection C equal to PA intersection C equal to 0. Also, this will be also 0. A with B with C will also be 0. When all of these are 0, you have the simply answer of this to be, please check, PA union B union C will become, bacha, PA plus PB plus PC, called as the case for mutually exclusive events. Mutually exclusive events. Let's move on now. Some important results we have again on the operations of addition, again union and intersections. Let's check the first one. At least 2 events. When we're talking about, let's start of 3 events A, B, C, we want only at least 2 to occur. At least 2 means maximum 3 also is okay, but at least 2 should be there. What do you write, bacha? A intersection B B intersection C, C intersection A. Why intersection? Because we want two, A and B or B and C or C and A, but two should be there, right? That's why intersection A with B, B with C, C with A, and removing the overlapping part A with B with C, it will come two times. That's why removed two times. Okay, now we are wanting not at least, only two, exactly two, because bacha, think about it, when I say at least two, no, I mean minimum of two, even more is okay. More means what bacha? 3 is also okay, allowed. 3 is also allowed, right? At least means minimum of 2, but more is also okay. That's why we have subtracted over here 2 times, okay? But in this case, when we say exactly 2 times, what will happen? We'll remove the 3 occurrence, okay? See here, there's a presence of extra intersection of all the 3. But in this case, we have removed that as well, okay? Means all 3 is removed, sir. All 3 is removed, right? We have minus 2 ABC. We have here minus 3 ABC. Extra, this was there in this case actually, but we have removed that part over here. If you want, you can draw a Venn diagram and check. Draw a Venn diagram and check, okay? Draw for 3 events and you'll see this. You will have extra 1 ABC hidden over here. That has been removed in this case because you're looking for exactly 2 of ABC, not 3. Exactly 2 means only 2 at a time. A union B or B union C or C union A, but not A, B, C together, right? So that's why we have removed 3 over here and over here only 2. Got it? Okay. Now we have exactly 1. So what will write, bacha? PA, PB, PC, and removing all the second level intersections and adding it once. Okay, exactly 1 of them, right? So removing this, because we'll end up removing okay extras as well, okay? We'll end up removing 2PA, 2PB. Do one thing, no? Cross check this. If you write this, have a look. PA plus PB plus PC, right? When you do that, you end up taking this also common items as well, right? We have common sections as well, no? Over here, please check this. The common parts are also there. So we end up taking that as well, okay? So when you do that, you are taking this, how many times? If you take PA, PB, you're taking this part 2 times, right? If you're taking PC also, you're taking this part again 2 times, right? So you have to remove that 2 times. When you remove 2 times, know what will happen? You remove 2 times of intersection of A and B, okay? This also you remove. What happens is you have taken out some extras as well. So that's why you have to add this up. 3P, A, B and C, okay? I'll tell you a simpler approach to understand this. Do one thing, name this part and see how many times it is coming out. Then you can add the extras, okay? So name this part to be 1, 2, 3 and 4. Do one thing, cross check, okay? Apply the same formula to this given Venn diagram and cross check. This formula will be valid, okay? For exactly 1. We want 1 at a time. Okay, moving on now. For any 2 events, of course, remember this intersection will be the minimum. You'll have the intersection as the minimum. Of course, any of the event will be more than the intersection, and the union will of course be more than the event itself, and the sum of the events will always be either equal to or more than. Remember here is given as equal to also, because then the cases will be for equal to also can be there. No, for mutually exclusive events, what will happen? This and this will be equal, right? That's what I'm saying. So any event will be more than the intersection, union will be more than any particular event, and the sum of the events will be basically more than the union also, right? Because in the formula you have intersection of B, AB, right? Please check. On this side, subtraction is there. So this side will be addition, please check. Okay, so this is done. Moving on. A pair of dice is rolled. Question number 1. So we have done all the concepts. Let's solve the questions also. I've taken a total of 4 questions. We'll solve them and complete the session. Okay. So a pair of dice is rolled. Consider the following events. Sum is greater than 8. Die is thrown, right? Greater than 8 can we take with 1? No. 1 and 6 is 7. 2 and 6 is 8. We can't take 2 also. We can take 3. So for the event A, I'm writing for the event A 3 comma more than 8, right? So 3 comma 6 I can take the first event. Next one, next will be I can take 3 comma 6 is done, so I cannot take this 4 1, no 4 4, no 4 5 I can take, and 4 6 I can take, right? this is more than 8. Okay, now 5 bacha, 5 3 I cannot take, 5 4 I can take, 5 5 I can take, and 5 6 I can take. Same way 6 3 I can take, 6 4 I can take, 6 5 I can take, and 6 6 I can take, right? These are the events for the samples for the event A. Now for event B, what I have, 2 occurs on either die. Okay, so I'll have 1 comma 2, then I'll have 2 comma 1, 2 comma 2. Either means both is also okay, na? Either A or B, or both A or B is also okay. So A 2 comma 2, same goes till 2 comma 3, please check, 2 comma 4, 2 comma 5, 2 comma 6, then we have 3 comma 2, 4 comma 2, 5 comma 2, and 6 comma 2. 6 comma 2. B is done. Event C, at least 7 and multiple of 3. At least 7 and multiple of 3. Please check. So first multiple of 3, more than 7 will be 9. So right here, please check. So I can write here with 2, I cannot write with 3, I can write 3 and 6 is 9, na? Sum is 9 as at least 7, so this is more than 7, of course. Please check, 3 6 is there. Multiple of 3, no? What else we can write? 3 6 is there. And we have, please check, yeah, 3 6 we have, and I can write like this, 3 6, then 4, no, 3 6 I cannot, anything else we have in 1 2, no, 1 to 6 will be 7 only, 2 2, anything we get, multiple of 3, 2 6 is 8, we can't do that. Okay, 2 5 is 7, 3 5 is 8, 3 6 is 9, then I take 4 5, na, 4 5, 4 6 4 and 2 I can't take, will be less than 7, so 4 5 is there, 4 6 we can't take, 4, yeah, then 5, then I can take 5 with 4, of course, 5 4 is 9, okay, 5 4 is 9, that's good. And then we can take 5 5, no, 5 6 also no. Then let's move on to 6 6 3 we can take, bacha. 6 3 is again 9, which is multiple of 3. 6 4 we can't take, 6 5 we can't take, 6 6 we can take. This is the multiple of 3, sum is multiple of 3, and of course is more than 7. Okay, now we are looking for intersection, right? Okay, we are looking for mutually exclusive, means we are looking for the intersection which is 0. We are looking for intersection which is 0. Okay, so let's check for A and B intersection. A and B intersection, sir. Anything like this is there? No, 3 6 is not there. Nothing is there. No, there's no term with 2 in it. There's no term with 2 in this. Is there? There's no term with 2 in this. Means of course, bacha, this will have no intersection. No, so A intersection B will be 0. So A and B are mutually exclusive. Okay, so this is okay. What about B and C? What about B and C? Again, over here also there's no intersection of, there's no 2 present in this any of the ordered pair of set C. For set C we don't have any of the ordered pair containing 2. It means again B intersection will also be 0. What about A and C? Please check A and C. A and C, sir, I have 3 6. I have 6 6 also, and I have 6 3 as well. So of course it is not equal to 0. So we have only these 2 pairs. Please check. I have answer as A and B and C. Option A is correct. Option A is correct. They're looking for mutually exclusive events, means they're looking for the intersection to be 0. I'm getting A and B as 0 and B and C as 0. It means A and B are mutually exclusive and B and C are mutually exclusive as well. So A and B are mutually exclusive and B and C are mutually exclusive. Clear? Moving on now to question number 2. The probability that in the random arrangement of letters of word favorable, okay, F A B L E, correct? 1 2 3 4 5 6 7 8 9 10. Okay, 4 2 4 6 8 10. 2 4 6 8 10. All right, the 2A do not come together. The 2A do not come together. Okay, what we can do now, we'll try to find an event P where 2 A's come together. come together. We'll find that, okay, we'll find this probability, all right, and from there we can find for our result, no, we can simply find P complement. Understand this very clearly. I'm gonna from the given whatever operation I have to use, I'll use that to find for an event probability P, two A's come together, always coming together, okay, and from there I'll find the complement to get the result as two A's do not come together. Getting my point? Okay. So if I'm taking 2A together, what will happen? I'll have total of, please check. So this will become one event. I can write this 2A together. Apart from this, I'll have total of 8 spaces, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 4, 6, 2, 4, 6, 8. This is not there, okay. So think about it. This can be clubbed together, froze together to become one, to become one, okay. So a total of 9, no, 1, 2, 3, because wherever it goes over here, wherever it goes, it'll be together only, right? So basically I have 9 factorial types of total number of arrangements, total number of arrangement or ways, okay. I have this as 9 factorial because total 9 factorial total I have. If I club them together, I get out of 10, one is clubbed together, right? So it becomes total of 9 spaces. So it can be either here, 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 like this, right? So it'll become 9 factorial, right? Total number of ways will be 9 factorial. Now what is total number of events, bacha? What is that going to be? Think about it. So I have total number of events to be 10 factorial, but 2 is coming together, right? Divided by 2 factorial. So this is for this case, right? For 8 coming together, and this is for entire event, okay? Means basically total number of ways. This is just for this arrangement for 2 A's to come together, and this is for entire number of for all the letters, okay? Total number of ways will be total. How many are there? 10, right? But 2 is coming together, right? We have to divide that by 2. So we have 10 factorial by 2 factorial, okay? Now we're looking for, let's say, finding the probability of the event P, okay? It'll become, so think about it, it'll become 9 factorial by 10 factorial upon 2 factorial, okay? So it'll become 9 factorial times of 2 factorial upon 10 factorial. So we can cancel this and this. It'll become so simply 10. So I'll have this as 2 by 10, excuse me. It'll become 1 by 5, right? So probability of the event P is given by 1 by 5. So now we are looking for probability of the event P complement will be given by 1 minus 1 by 5. It will become so 4 by 5. It will become 4. What is this, bacha? PC means 2A do not come together. 2 A's do not come together, because A was, this P event was 2 A's come together, okay? 2A come together. In this case, 2A do not come together, okay? So answer is 4 by 5. Option D is correct. Option D is correct. Excellent question. Please check. This is done. Moving on now. Question number 3. If we have 1 plus 3p by 3, 1 minus 2p by 2 are probabilities of 2 mutually exclusive events, okay? All right, P lies in the interval, mutually exclusive events, right? So let's say let's call this event A to B, by 3, and PB is 1 minus 2P by 2, okay? So basically intersection will be nothing but 0, right? Okay, so we have PA plus PB equals to PA union B. We don't have any information on union, okay? So can we apply the condition for the probability? Axiomatic probability we can apply in the condition. So understand this. This will be again less than 1, less than equal to 1 and more than 0. So I can write this 1 plus 3p by 3 will be more than equal to 0 and less than equal to 1. And the other one, if please check over here. For the other one we'll have again same condition, 1 minus 2p by 2 is less than equal to 1. Please check and can solve this. It will become 0, sir. So I'll have 0 less than equal to 1 plus 3p less than equals to 3. I'm cross multiplying 3 over here and over here. I get 3 into 1 is 3 and 3 into 0 is 0. Now move this 1 on this side, I get minus 1 less than equal to 3p less than equal to 3. So I get here minus 1 by 3 less than equal to p less than equal to 1. Right? Chali. Have a look. Okay, this is done. Right? Right. We have alright, 1 plus 3p should be less than equal to 1. If I move this, okay, no, I made a mistake. Excuse me, I made a mistake, sir. What is the mistake? I moved this 1 on this side also, no? I have to move this 1 on this side as well, right? So it becomes it'll become 3 minus 1, no? So it'll be 2 actually. So answer will be 2 by 3 actually. It'll be 2 by 3, sir. Excuse me. It'll be 2 by 3, sir. 2 by 3. Please check. Because 3 minus 1 will be there, no? I have to move this 1 on both sides. So it will become 3 minus 1 is 2. Divided by 3, so 2 by 3. The answer will be minus 1 by 3 to 2 by 3 for P. But we have to take the intersection of both. Okay, please check. Second event, if I do this, I move this 2 on this side. I get here 0 less than equal to 1 minus 2p less than equal to 2. Okay. Now I'm gonna do one thing. Move 1 on this side and 1 on this side. I get here minus 1 less than equal to minus 2p less than equal to 2 minus 1, right? So plus 1 simply plus 1. Okay, now what I'm going to do is simply multiply with minus sign. So what I get this as plus 1 greater than equal to 2p greater than equal to minus 1 divided by 2. I get here 1 by 2 greater than equal to p greater than equal to minus 1 by 2. Okay, so if I write this in this form, rearrange it, minus 1 by 2 less than p less than 1 by 2. Now check here intersection, bacha. The smallest of these two values for the lower limit is this one. Okay, so basically if I combine these two together, I get this as p belongs to, please check, smallest of these two, so minus 1 by 3 close interval, and you'll have over here 1 by 2. Okay, answer will be option A. Option A, please check. Answer will be option A. Done. Moving on to the last question. Let's complete the session. So we have one ticket is selected at random from 100 tickets numbered 00. So ticket has a number, okay? 001, okay, 01. Excuse me, 0001. Okay, next will be sir 02. And so on till 99. Okay. Total we have 100 tickets, right? From 00 to 99 means total is 100 tickets. Total is 100 tickets. Okay, great. What are they asking now? S and T are sum and product of the digits of the number on the ticket. Okay, S means, what is it? S means sum and T means product. Okay, then the probability of the getting S equals to 7. Okay, now sum is 7, this sum is coming as 7 and product is 0. Product is 0 means, sir, let's say if I take this numbers, if product is 0 means, sir, it has to be, one number has to be always 0, whether this or this doesn't matter, right? And the sum is 7 means, sir, of course other has to be 7. Is this the only possibility? No, I can also have 70. I can also have 70. Please check. Somewhere over here I'll have 07 and somewhere over here I'll have 70. Both will give me sum to be 7 and product to be 0. Hence our probability will be total favorable is 2. These two are my favorable outcome. So 2 upon total probability or total outcomes, which is 100. Answer is 1 by 50. Option D is correct. Please check. Option D is correct. This completes your session. Okay, so I hope you had fun. I hope you learned something in the PU section of PU probability. Okay, it's a good chapter and it has a weightage as well, so it is very important to learn this chapter. Again, very helpful if you know this basics of probability. No, it'll be helpful for you to understand the chapter in PU2. Okay, so we'll complete it over here. I hope to see you again very soon. Till then, keep working hard. Okay, take care. Bye bye.